Good morning, calculus class. What we are looking at right now and about to start is section 6.4. Very similar to what we've been doing already in 6.1 and 6.2. Just takes it a little bit of a step further. But before we get into what section 6.4 actually is about, what I want to do is go over and review 6.1 and just give you one example of how we solve a differential equation. So if we're going to solve dy dx equals 3x squared when x equals 1, say y equals 2. So, again, these are what we call the initial values. So this is the type of problem, when you see this, you're actually going to find that value of the constant. You're going to find c at the very end. Before we can do that, however, we need to essentially integrate both sides of this equation, which we do by multiplying dy dx to this side. So you get 3x squared dx on the right-hand side of your equation. And now you can integrate both sides. The antiderivative of 1 dy is y. And the antiderivative of 3x squared is just x cubed plus c. Right? And so, once you separate your differentials, dy and dx, you can integrate both sides, and now you can plug in your initial values of 1 and 2. So y is 2 when x is 1. So 1 cubed plus c. You're going to get 2 equals 1 plus c, therefore c equals 1. So our solution to this problem is y equal x cubed plus 1. And that's how we solve a differential equation. Okay? And so that's just a quick reminder on how we solve. We do that by integrating both sides. And then when you have these initial values, you actually are going to go back and find your c value at the end. Notice how you typically want to plug it in, or substitute in your values for your variables as soon as you integrate and get your plus c. On the problems we're about to do, that is going to help you avoid mistakes in your algebra. So, it might be a good time to pause your recording right now and start these notes and write this example. This is what we call a separable differential equation. It's not a whole lot different than the one we just did. However, now we have a y term, or a y portion of this term, that we need to separate from the x portion of this term. So again, we have our initial values here that tell us, okay, what we're going to substitute in to find c. But the first thing we have to do in order to solve this, step 1 really, is separate the dy's, y's from the x's and dx's. So from the dx's and x's. So that's it, really. So dy dx equals y squared cosine x. Well, we'd multiply dx over, and we would divide by y squared, so that you get the before we integrate, you get dy over y squared equals cosine x dx. And now step 2 is to just solve like we did the last problems, like we did on the bell work and we did in 6-1. You integrate both sides. So again, we could write 1 over y squared as just y to the negative second power dy. And that's going to equal the integral of cosine x dx. Right? And so when we integrate y to the negative second, you have to add 1 to your power and then find your coefficient, which in this case, when you multiply down a negative 1 to get back to the negative 2 power, you just need a negative in front. So we have negative y to the negative first equals sine x plus c. So again, step 1, you separate your y's and dy's from your x's and dx's, which we did here. And now step 2, we just solve, similar to what we did in a previous section. So now that we know this, we can plug in for x and y. And again, I would do this right away. So we have negative times 1 to the negative first power equals the sine of pi over 2 plus c. Because we want to find c, we want to find the exact solution to this. Not this whole family, but the exact solution. So negative 1 to the negative first is just negative 1 equals sine of pi over 2, which is 1 plus c. In order to solve this, you'd subtract 1 from both sides. You'd end up getting negative 2 over here, so c equals negative 2. Our exact solution right now is going to look like negative y to the negative first equals sine of x minus 2, because c is negative 2. But in this case, we do have more work to do. Your third step is then to solve for y right now. So we need to solve this for y. So if we multiply by negative 1, you get y to the negative first equals negative sine x plus 2. And now because this is y to the negative first, if we just find the reciprocal of that and call it y to the first, we'll have to find the reciprocal, or just say that the reciprocal of y to the negative first equals the reciprocal of negative x plus 2. So this is going to give us 1 divided by negative x sine x plus 2. And that's our answer. So y would equal 1 divided by negative sine x plus 2. That is the exact function that if you found the derivative of this, which we can do, would get us all the way back to what dy dx is equal to. That pretty much concludes the video. The only thing left to do is assign some homework on these. There's a lot more in section 6.4, but we're going to look at that at a later date. So what we need for right now, and this will be due the next time that we meet, so the next class period where many of you will actually be in class, it's section 6.4, and then it's just numbers 1 through 10 all. So 10 problems, and that's due the next time that we meet. Okay, thank you. Have a great day.